Welcome back, everybody. Ready for another deep dive?
Always.
Awesome.
Yeah.
So today we're taking a look at single-slit diffraction.
Oh, that's a good one.
Yeah, and you gave me some fascinating resources for this one, including stuff from open educational resources, open source physics at Singapore.
Yeah.
And they have a really, really broad range of topics like kinematics and energy. They even have a section on circles.
Huh.
But we're zeroing in on one very specific phenomenon today.
Right. And it's one that might sound a little, well, niche.
Yeah.
But it really reveals some pretty fundamental things about how light works. Beyond just like, spreading out.
Okay, yeah, I was just thinking about that. We've all seen light sort of peek through a doorway
Yeah.
or spread out, after passing through a narrow opening. So is that all diffraction is?
Well, it's a good starting point, but single-slit diffraction is really about the wave nature of light.
Okay.
So imagine like waves on a pond.
Yeah.
They don't just like stop abruptly at a barrier, do they?
No, they kind of curve around.
Right, they bend around it, and light does the same thing. And importantly, it creates a pattern, not just a blur.
Oh, okay. So there's like a predictability
That's
to it.
exactly. When light waves pass through a single slit, they interfere with each other in a very specific way, creating these alternating bands of light and dark areas.
Interesting.
That's the diffraction pattern.
Okay.
And the dimensions of this pattern, they're directly related to the width of the slit and the wavelength of the light.
So it's not random at all. It's very specific.
Very specific, yeah.
And I see from this website that they have like a simulation
Oh, cool.
where we can actually visualize this happening.
Yeah, simulations are really great for understanding physics concepts.
I love a good visual. Yeah.
Me too, me
Got it.
too. This one, from what I can tell, it lets you adjust variables like, the width of the slit or the wavelength of the light. And you can actually see how those changes affect the diffraction pattern.
Real time.
Real time, yeah.
Very cool. And it mentions that the simulation is built using something called, and I'm going to try to get this right, 2D scalar element.
Yes.
Now, I'm not entirely sure what that means.
So, without getting too technical,
Yeah, let's keep it high level.
scalar elements are basically individual points of data that represent a specific value.
Okay.
So by arranging them in a 2D grid, the simulation can actually show the light wave as it interacts with the slit
Oh, I see.
with a really high level of detail. It's almost like, the difference between a simple line drawing and a really high-resolution photograph
Oh, okay.
in terms of the amount of information they can show.
So it's a more, I guess, sophisticated rendering
Yeah.
technique
Exactly.
for a more accurate representation of the physics.
Exactly.
Makes sense. And speaking of accuracy, I noticed this website has a research section
Oh, yeah.
along with some sample learning goals.
Yeah.
Are those hinting at, like, the deeper implications of diffraction?
Oh, absolutely. Understanding single-slit diffraction, it's not just about passing a physics exam.
Right.
It's really fundamental to a lot of scientific fields.
Interesting.
Like, think about telescopes, for instance.
Telescopes. I wouldn't have immediately thought about those with single-slit diffraction. How so?
Well, you see, telescopes use lenses or mirrors, right?
Right.
To gather light from faraway objects.
Yeah.
But because of diffraction, even with perfect optics, that light's always going to spread out a little bit
Oh, okay.
as it passes through the aperture of the telescope.
Uh-huh.
This spreading, it creates a blurring effect,
I see.
which ultimately limits the telescope's resolving power, its ability to tell the difference between two objects that are really close together.
So even with, like, the most powerful telescopes out there,
Yeah,
there's a fundamental limit to how sharp of an image we can get
exactly.
because of this wave nature of light.
It's not just theoretical either.
Oh, wow.
It has real-world implications for, how we understand the universe. Like, diffraction makes it really hard to see the fine details of really distant galaxies.
Oh, okay.
Or, to pick out individual stars in crowded star clusters.
That's pretty mind-boggling.
Yeah.
That something as seemingly simple as light bending around a slit
Right.
can impact our ability to see the cosmos.
It's a great example of how, physics concepts
Yeah.
have tangible consequences.
For sure.
And this website really does a good job of connecting those dots. It's not just presenting the theory
Yeah,
in isolation.
that's true. I'm looking at these sample learning goals again,
Yeah.
and one of them mentions calculating the width of the central bright band in a diffraction pattern.
Mm-hmm.
Is that something that would be relevant to say, a telescope designer.
Oh, absolutely. Understanding how that width changes, with the width of the slit
Right.
and the wavelength of the light. That's crucial for making sure the telescope is designed properly.
Interesting.
You want to get as much light as possible.
Yeah.
But minimize those blurring effects from the diffraction.
It sounds like there's a lot of, I don't know, complex math and physics behind all this.
Oh, yeah.
But it's cool to see how it all connects back to something as, I guess, fundamental as light itself.
Right.
And the website also mentions that single-slit diffraction is connected to other concepts like superposition and general waves. Does that mean it's just one piece of a much larger puzzle in physics?
Exactly, yeah. Single-slit diffraction is a really, really good entry point into understanding, wave phenomena in general.
Okay, so like all those.
Yeah, all sorts of waves, not just light, we're talking sound waves, water waves, even seismic waves exhibit diffraction.
So what we're learning here about light bending and creating these patterns can help us understand how waves behave in all sorts of different contexts.
Exactly, and it really shows how powerful physics is, at revealing these underlying principles that govern the natural world.
That's really cool. You know what else I'm noticing? How well organized this website is.
Yeah, it's great, isn't it?
Even something as simple as the breadcrumbs navigation. It helps me see where this topic fits, into the bigger picture of physics.
And that structure's so crucial, especially if you're new to a topic.
Yeah, I could see that.
It gives you, a roadmap, a sense of where things are, prevents information overload.
It's like they've anticipated the learner's journey.
Yeah.
And given them like all the signposts they need along the way.
Exactly. And that brings us back to those sample learning goals.
Right.
They kind of act as guideposts within the topic itself.
Oh, okay.
Prompting you to really think critically.
Yeah.
And apply what you're learning. Like there's one about predicting how the diffraction pattern would change if you used a different color of light.
Oh, that's a good one.
Right.
Makes you think about the relationship between wavelength and the characteristics of the pattern.
Exactly. It's not just passive, You're actively engaging with the information.
And that active engagement, that's key.
Yeah, it's key to really, really understanding it. It's not just about, memorizing facts.
Yeah.
It's about developing a feel for how things work.
And intuition.
Yeah, an intuition.
This deep dive has really, I have to say, given me a new appreciation for light.
Yeah.
And how intricate it is and the way it interacts with everything around us.
Yeah, for sure.
I have to admit, when we started, I didn't expect to be thinking about, the limits of telescopes or the bigger implications of wave phenomena.
It's always surprising where a deep dive takes us, isn't it? But even just sticking with, the single-slit diffraction, what stood out to you the most? Like, what was the most unexpected thing?
For me, it's that this phenomenon, which we can observe, like, with pretty basic stuff.
Yeah, totally.
A laser pointer and a piece of card.
A laser pointer, yeah.
Can have such profound implications
Mm-hmm.
for how we understand the universe.
Yeah.
It's like it highlights how connected science is,
Yeah.
How a seemingly simple observation can lead to deeper insights about, I don't know, reality itself.
Yeah, it really makes you wonder, though, if diffraction imposes these limitations, are there ways to work around them?
Yeah, that's a great question. And, it makes me think about all the amazing images we see from space telescopes.
Right.
I mean, they must have found ways to deal with that blurring, right?
Yeah.
The blurring caused by diffraction.
They have. To a certain extent, like adaptive optics, for example, that uses deformable mirrors.
Oh, wow.
To compensate for the distortions that Earth's atmosphere causes.
Okay.
And then there's interferometry, which basically combines light from multiple telescopes.
Okay.
And that can effectively increase the aperture size, leading to, sharper images.
So we can't completely get rid of diffraction.
Right.
It's like you said, a fundamental property of light.
Exactly.
But we can use some pretty clever engineering to kind of push the boundaries of what we can see.
Exactly. It's really amazing what we can do.
It is. And it's a real testament to, I guess, human ingenuity.
Yeah.
And our desire to learn,
Absolutely.
to keep exploring and figuring things out.
Yeah.
Well, this has been a really eye-opening deep dive.
It has.
We started with something that seemed, relatively straightforward, light bending around a slit.
Yeah.
And we ended up talking about the limits of telescopes.
Right.
and the vastness of the universe.
Yeah. It's amazing how these things connect.
It is. It is.
Yeah.
It's a great reminder that even, what seem like basic physics concepts could lead to some pretty profound insights.
Yeah, for sure.
And spark a deeper curiosity about the world.
Absolutely.
I gotta say, I feel like I've learned a lot today.
Me too. Me too.
And it's a good reminder that there's always more to discover.
Right. Always something new to learn.
Always another layer to uncover.
Yeah.
And who knows what other surprising connections we might find, as we keep going.
Exactly. That's what makes it fun.
It is. It is. Well, a huge thank you to you for walking us through all of this.
Oh, you're welcome. It was my pleasure.
And to all of you listening out there, thank you for joining us on this deep dive.
Thanks, everyone.
We'll see you next time. Keep those curious minds engaged, and let us know what other fascinating topics you'd like us to explore.